Hello, my name is Gary Marr, and this screen captures from my SAS 166 AA JavaScript class. I've got a bit of a cold, so you might hear a cough. You're certainly not going to hear my normal voice, but I'm going to struggle through this anyways. This particular example is of custom classes in JavaScript. This is not a particular topic that's widely used. Typically, you're giving the class objects by JavaScript. You're just going to reference them. Things like window and date and document, things like that. You will see it use the dot notation that we've used in class, document dot write name, document dot write, etc. And what I've done here is basically giving you two files. One is just a standard HTML file that simply does a call to the external JavaScript. And the other file is the external JavaScript. This is on the S drive in the week 13 folder. It basically consists of two functions and a call. First call basically says that after the form is finished loading, you should run a function called main. So down below here is the main function. Here it is. This is the main driver logic of this program. The first thing that it'll do is create a new variable called myStaff that's going to be of a type of staff, which is the custom class that I'm building. I'm going to use the new keyword to instantiate this in memory. And instantiation is a key concept object-oriented programming. It means I'm going to take that class called staff, which I more or less have a blueprint of, and I'm now going to store information about that particular instance of staff, which I'm calling myStaff. Now, if you follow the rest of the code here, you're going to see some stuff that's somewhat familiar, like the prompt function. And then you're all going to also see myStaff, that variable that I just created, a dot, using the dot notation. Again, we're using classes. Set name, which is the name of a method, and then I'm going to pass it information called staff name, which I just captured here in the prompt. The same thing will happen with title and salary, and then finally down here in the document write, another class object, I'm going to call myStaff.staffData, which is a method inside the class object to display some information. That's the main program. That pretty much drives the process. The class in itself is executable code only if it's instantiated. Otherwise, it just sits here like an uncalled function. The class is identified by the function keyword, and as following the traditional class naming conventions, or object-oriented programming naming conventions, I want staff to start with a capital S. That's kind of a trigger to indicate it's a class name. You'll see in yellow here the keyword this. And what this is saying is I've got three variables which I'm going to initialize with a constructor. The constructor is called automatically when the class is instantiated. So when I said myStaff, it's going to go up here, it's going to build these three variables, and it's going to initialize their variables, or their values. Below that are mutator and accessor methods, sets and gets, set name, get name, set title, get title, etc. The set is used to give the variable name a new value, and the get is used to retrieve that. Now the reason they're doing this is for encapsulation. And since so much of object-oriented programming is about code reuse, the reason we use sets and gets to support encapsulation is also to support data hiding, where we can give this class object to another programmer, along with an API that explains what then the set and the get does, and they can then call those out and use them. There's no real need for them to know what the details are behind these methods. Currently, there's not behind much of these at all, but probably if this was a more traditional build, I would on my sets have some sort of validation which would basically have maybe some logic that said if name could not be blank and I tried to add a blank name, it would kick back an error message because that would break my class. And if I want this to be reused correctly, I have to reinforce its basic design. So I've got some sets and gets, and then down here at the bottom is my staff data method, which is a more traditional method, which is simply going to return a bunch of information about this class. Now, as far as these things that are called methods that do not have the function keyword, they do have this prototype keyword. And essentially the way that custom classes work in JavaScript is that you define your internal methods to be like properties. And you do that with a property or the prototype keyword. Now, as far as running this goes, I will go over to my test class here. And all I would do is execute this code. I'm probably going to have to move this screen because it's going to be outside the window, but let me do that. Let me run this in Chrome. And up there it is. And basically there's my first prompt. Let's put a letter in there. My second prompt is going to be boss. My third prompt is going to be 30, and then I'm going to hit OK. And then at this point, it's called that internal method, which is going to display my name, my salary, and my title. Excuse the mixed case typing there. So all of that information is contained inside the JS file. And this is a very simple example. Java custom classes are not that common. Typically what will happen is you'll call classes that come with Java, but it's not that usual to create your own. But hopefully this helps you in better understanding JavaScript custom classes. Thank you.